For as long as mankind has been observing the heavens, we have been fascinated by the possibility that other worlds might contain living organisms. While our visits to the moon have taught us that it is barren, other planets in our solar system show potential. Europa and Enceladus could be teeming with life in subsurface oceans of liquid water. But perhaps the most intriguing target in our search for extraterrestrial life is our neighbouring planet Mars. So, let's start with the most conservative viewpoint. Imagine, if you will, a young Mars, billions of years ago. It had the same raw materials as early Earth: water, volcanoes, organic molecules. It even had similar water conditions. But something was missing. The necessary circumstances to allow life to form simply never occurred. Now, this doesn't mean Mars was a boring, inactive place. All the geological and chemical processes that occur inorganically did take place. Volcanoes erupted, spewing lava and gases into the atmosphere. Rivers flowed, carving canyons and depositing sediments. But no organic activity, no self-replicating molecules, no single-celled organisms, nothing. Then, a little over 3 billion years ago, disaster struck. The Martian atmosphere, once thick and protective, was stripped away by the sun. This had a devastating effect on the planet. Any liquid surface water evaporated or froze, leaving behind the dry, desolate landscape we see today. Let's explore another possibility. What if there was early life on Mars, but it died out? Imagine a Mars that was once teeming with microscopic life. Picture this: a world with a dense atmosphere, stable liquid water, continents rich in geological diversity, volcanoes erupting, a magnetic field, and temperatures only slightly cooler than today's Earth. This was Mars billions of years ago, and it's a scenario that could have led to the flourishing of life. But as we know, Mars underwent a dramatic transformation. The loss of its atmosphere had profound effects, turning it from a potentially habitable world into the cold, dry desert we see today. This catastrophic event may have led to the extinction of all life on Mars, leaving behind only tantalizing clues of its past existence. To prove or disprove this theory, we could drill into the sedimentary rocks of Mars. These rocks preserve a record of the planet's past, and if life existed, there's a chance that some evidence might still be preserved. We might find fossilized life forms or chemical signatures hinting at past life. Even the discovery of extinct life would be monumental, proving that Earth is not alone in harboring life. Now let's delve into a tantalizing possibility. What if Mars harbored early life, and it still persists today, hidden beneath the surface, waiting to be discovered? Imagine this: billions of years ago, life arose on Mars, just as it did on Earth, thriving in its ancient oceans and lakes. But when Mars lost its atmosphere and its surface became uninhabitable, some hardy organisms retreated underground, seeking refuge from the harsh conditions. These extremophiles, capable of surviving in extreme conditions, found refuge in a kind of frozen limbo, much like their counterparts on Earth. Deep beneath the Martian surface, where liquid water can still exist due to geothermal heat or the pressure of the overlying ice, these dormant life forms could be patiently waiting for the right conditions to reawaken and flourish once more. Perhaps they lie dormant in pockets of liquid water, their metabolic processes slowed to a crawl, conserving energy until a time when they can once again thrive and multiply. If this is the case, then there are still organisms beneath the Martian surface, perhaps in the shallow sand, just a few feet or even inches below the Mars rover, waiting to be unearthed. It's likely to be only single-celled life. But finding even the simplest life on a world other than Earth would be a revolution for science, opening up new avenues of research and discovery. The implications of finding extant life on Mars would be profound, reshaping our understanding of biology and the potential for life elsewhere in the universe. It would change our understanding of our place in the cosmos and inspire us to explore the universe with renewed vigor and curiosity. NASA's Perseverance rover, which landed on Mars in February 2021, is equipped with tools to search for signs of past and present life, including sophisticated instruments to analyze the Martian soil and atmosphere. It will collect soil samples from the Martian surface, which will eventually be returned to Earth for analysis, potentially unlocking the secrets of Mars' hidden life. Let's consider a rather intriguing possibility. What if there was no life on Mars until pieces of Earth carrying terrestrial life crashed into it? This idea might sound like science fiction, but it's grounded in scientific plausibility. Picture this. 65 million years ago, a massive asteroid slammed into Earth, creating the Chicxulub crater and throwing up enough dust and debris to envelop the planet. The force of this impact was so immense that it changed the course of life on Earth forever. This cataclysmic event, which wiped out the dinosaurs, also ejected pieces of Earth into space. These fragments, carrying the building blocks of life, were sent hurtling through the cosmos. Just as impacts on the Moon or Mars sent meteorites to Earth, the Chicxulub impact sent material from Earth to other worlds, including Mars. This interplanetary exchange of rocks is a fascinating aspect of our solar system's history. We've found Martian meteorites on Earth, so it stands to reason that Earth meteorites must have landed on Mars as well. This exchange suggests a cosmic connection between our two planets. Now imagine that some of those Earth rocks carried tiny hitchhikers microorganisms, the hardiest forms of life on our planet. These resilient life forms are known to survive extreme conditions. These microscopic travelers, shielded from the harsh conditions of space by their rocky vessels, embarked on an unplanned journey to Mars. Their survival would depend on their ability to withstand the vacuum and radiation of space. Upon impact, these Earth-based organisms found themselves on a new world. The Martian environment, though harsh, presented new opportunities for life to take hold. Some may have perished, but others, perhaps more adaptable, may have found a niche where they could survive and even thrive. The ability to adapt is a hallmark of life on Earth. Over millions of years, these transplanted Earthlings could have spread across Mars, establishing a foothold on a planet that had never known life before. This slow but steady colonization could have profound implications. They would have evolved in isolation, adapting to the unique conditions of their new home. This evolutionary journey would be unlike anything seen on Earth. If this scenario is true, then the search for life on Mars takes on a whole new meaning. It becomes a quest to find our cosmic cousins, life forms that share a common origin with us. We wouldn't just be looking for alien life, we would be looking for long-lost relatives, descendants of Earth life that embarked on an incredible journey across the solar system. This possibility adds a new layer of excitement to our exploration of the Red Planet. Now, let's consider a scenario that keeps astrobiologists up at night. What if our modern space program inadvertently spread Earth-based life to Mars? This is not just a theoretical concern, but a real possibility that has profound implications for our understanding of life beyond Earth. For billions of years, Mars was a pristine, untouched world, at least from a biological perspective. Its surface, though harsh and barren, held the secrets of a planet that might have once harbored life. But with the dawn of the space age, everything changed. Our relentless pursuit of knowledge and exploration led us to send numerous missions to the Red Planet. Humans, in our quest to explore the cosmos, began sending probes, landers and rovers to Mars. Each mission carried the hope of uncovering the mysteries of our neighboring planet. Despite our best efforts, we can never be 100% certain that our spacecraft are completely sterile. The rigorous sterilization processes, though highly effective, cannot guarantee absolute cleanliness. Microorganisms, those masters of survival, can endure the harshest conditions, hiding in nooks and crannies, clinging to surfaces, waiting for a chance to thrive. Their resilience is both fascinating and concerning. It's possible that some of these microscopic hitchhikers made the journey to Mars aboard our spacecraft, surviving the launch, the journey through space, and the descent through the Martian atmosphere. Their journey is a testament to the tenacity of life. Once on the surface, they may have found themselves in a surprisingly hospitable environment. Mars, with its occasional liquid water and protective soil, could offer a refuge for these tiny travelers. Imagine this, a tiny microbe, dormant and shielded from the harsh Martian environment within a spacecraft component, finds itself deposited on the Martian surface. This microbe, though small, carries the potential to alter the Martian ecosystem. Over time, wind or dust devils could carry this component and its hidden passenger to a location where conditions are more favorable. The dynamic Martian weather could play a crucial role in this process. Perhaps it lands near a source of subsurface water ice, or in a region where temperatures are slightly warmer. These microenvironments could provide the necessary conditions for life to persist. With a bit of luck and a lot of resilience, this microbial stowaway could find itself in a position to survive and even reproduce. The possibility of Earth life thriving on Mars is both exciting and alarming. This scenario is the ultimate nightmare for astrobiologists. The contamination of Mars with Earth life could compromise our search for indigenous Martian life. We've been searching for signs of life on Mars for decades, and just when we're on the cusp of finding it, we might have accidentally contaminated it with our own. This would be a significant setback for planetary science. The worst-case scenario would be that simple life of Martian origin survived on Mars, but that terrestrial life, brought there by our spacecraft, outcompeted it, leading to the extinction of the very life we were hoping to find. This would be a tragic irony, highlighting the unintended consequences of our quest for knowledge. As we continue to explore Mars, the question of whether or not it harbors life, past or present, remains one of the most compelling mysteries in science. The possibilities are as vast as the Martian landscape itself. Perhaps life never arose on Mars, or maybe it did and was extinguished by a cosmic catastrophe. Or perhaps life persists on Mars today, hidden beneath the surface, waiting for the right conditions to re-emerge.